Robin Higgins, and this is What Does a Low pH for Maximum Rate Tell You About the Structure of an Enzyme? Okay, so just a refresher, an enzyme is a catalyst made of proteins. So basically nature's catalyst. If there's a reaction, of which there are thousands, that needs to happen, most usually faster, sometimes slower, then an enzyme will step in and it will kind of make that reaction happen a lot faster, but it won't be affected. So that's an enzyme. All right, so enzymes are all just single strands of amino acids, like all proteins. And they all have a very specific 3D structure. So in nature, you won't find an enzyme that's just a straight line like this. They all have a very specific 3D structure that looks kind of crazy and mangled, but is very particular. And they're held in that way by usually hydrogen bonds. So if you have like an alcohol sticking off of one of them, and over here you have something that it can hydrogen bond with, and when it folds, maybe this ends up finding this and they form a little bond like that. So, but because of thousands of these, enzymes have a very particular 3D structure. And so enzymes also have a maximum rate. And the maximum rate is basically the settings where it's ideal for that enzyme. So it involves temperature and also pH. So over here we have a table of the optimum pHs for a few different enzymes. So you can tell that lipase in the pancreas has an optimum pH of 8. Remember that neutral, so just like plain tap water, is 7. And if it's in the stomach, it will actually have a pH of 4.5. So any number that's below 7 is acidic. Any number above is basic. So we can tell from just lipase that some of them that are in the stomach are much more acidic than the ones that are in the pancreas. And this makes sense because we know our stomachs are full of stomach acid because that helps us digest our food. And so just take a look at some other enzymes. You have pepsin 1.5, so extremely acidic, maltase 6.5, a tiny bit acidic, and then catalase, which is pretty much neutral. So these enzymes all have different optimum pHs, and you can kind of tell, like for instance the stomach, where they'd be located in the body based on the pH. And remember, they all have their optimal temperatures as well. So how do you relate structure to function and pH? Well, the answer is that that's really, really complicated. And right now, scientists figure out what an enzyme does by doing 3D modeling of it and seeing where there are pockets for reactions to happen. So they don't really do it based just by looking at structure or looking at optimum pH. So enzymes are very complicated and there's thousands of them. So right now we kind of can know the optimum pH, we know the structure, we know the function, we connect all of them, but it's hard to look at one and guess the other two. So that will come much down in the future, or maybe people just forget about it. I'm Robin Higgins, and this has been What Does the Structure of an Enzyme Have to Do with its Optimal pH?